Welcome to another episode of the Geotechnical Engineering Podcast, a podcast focused on helping geotechnical engineers stay up to date with technical trends in the field. I'm your host, Jared Green, and I've practiced as a geotechnical engineer for over 17 and a half years. In addition to practicing engineers, I enjoy mentoring young engineers and first-generation college students. I focus on helping to increase the number of pre-college students that are interested in STEAM majors and fields. By STEAM, that's science, technology, engineering, art, and mathematics. In this episode of the Geotechnical Engineering Podcast, I'll be talking to Scott Olson, professor of Geotechnical and Civil Engineering at the University of Illinois at Urbana-Champaign. We're talking about his career journey, including talking about static and seismic liquefaction, and providing some of the latest updates regarding residual strength of liquefied soils. Scott Olson, Ph.D., PE, is a professor and faculty excellence scholar in the CEE department at the University of Illinois, where he joined the faculty in 2004. At Illinois, Professor Olson has offered several geotechnical engineering courses. Prior to joining the faculty at Illinois, Scott worked in practice for over 7 years at Woodward Clyde Consultants and URS Corporation. Professor Olson has researched static and seismic liquefaction for nearly 25 years and has been involved in dozens of research and consulting projects involving geotechnical engineering, geotechnical earthquake engineering, and tailings dam engineering. Dr. Olson's other research interests include laboratory and centrifuge testing, paleoliquefaction, in situ testing, geohazard analysis, and soil foundation structure interaction. From these activities, Scott has published over 140 journal papers, conference articles, and reports, and has received numerous awards for his research and teaching, including the ASCE Arthur Casagrande Professional Development Award and the Walter L. Hubert Civil Engineering Research Prize and the Canadian Geotechnical Society R.M. Quigley Award. He is a licensed professional engineer in the state of Missouri. And with that, let's get right into our conversation with Professor Olson. Professor Olson, welcome to the Geotechnical Engineering Podcast. We are honored to have you. How are you feeling?
Doing great, Jared. It's nice to see you again.
Excellent, excellent. All right. Well, if you could, we introduced you earlier in the show, but in your own words, can you tell our listeners a little bit more about yourself and some of the things you do at your job at University of Illinois, Urbana-Champaign?
Sure. You mentioned that I'm a professor of civil and environmental engineering, but while a lot of students and other professionals have some impression of what they think professors do, I don't know that necessarily it's the right impression. Of course, the first thing about being a professor is education. We want to develop and train the very best next generation of geotechnical engineers and engineers in general, inside and outside the classroom. I mean, you're a great example. Hopefully I'm a decent example of what that education can provide to you. On top of that, we're doing research year round at Illinois. A lot of folks say, well, you just had you get a long summer vacation here. You should really be out enjoying yourself. And I'm like, no, I'm just like you. I'm down in my basement right now doing research, talking with my students and writing papers. And so, my main focus in terms of research is conducting and publishing research that's really going to impact practice, at least the niche of practice that I'm engaged in. So I don't really get into the esoteric stuff, and it's never really been that interesting to me. Fundamentals, certainly I'm going to mention that many times, I imagine, and how important that is, but I want to conduct research that's going to impact practice, that's going to change the way we do things as practitioners. Then, of course, there's mentoring. You think of mentoring as something that when you get out into practice, you have a supervisor or someone else that mentors you. But of course, we're mentoring students and Ph.D. candidates and postdocs at the university level too, helping them develop and decide on their next career step. Whether that's going into practice or going into academics at some point. Service is a really important piece of what we do.
Definitely.
We have to participate, and for us, it's an obligation more so than, or hopefully it's also a desire, but it is an obligation to some extent to get involved in those non-university related things, from serving on committees to working with national technical committees, to doing all those things to make sure that we project the right image of our profession and make sure that we give back to more than just our students and the university, to kind of broaden our reach. And then, of course, practice is still an important piece for a lot of faculty members, myself included, that I like to stay involved in consulting work and in practice so that I know what's going on, and so that I can offer my students a little bit different perspective on what the next step of their career might be.
That's awesome. That's awesome. And when you think about your career, I would say that you've had a successful career. How would you define success in your career?
For me, it's, the first and foremost, it's that my students are doing well. And that's both the students that I'm doing research with, but also just the students in my classroom, that I want to make sure that they are well prepared for that next step, so that if they go out into practice, they are ready to work on the most challenging projects that are out there. And hopefully, then if I prepare them well and they get involved in these projects, they give me a call and say, hey, I'm working on this stuff. Can I give a talk about it at Illinois? Or we need some help. Can you, lend us a hand on this particular project? So again, it kind of all is circular so that I can remain active and remain involved, but I want to get those students out there as part of our profession. And then for myself, my metric is that my research, again, is having an impact on practice, that I see. It's not about seeing your name, but it's about, again, having that impact and making sure that the time that I spend doing research, and my wife tells me I spend a lot of time doing that sort of stuff. She reminds me how many hours, that it's actually has some value and it's going to be utilized and not just stuck on a shelf somewhere in a book that nobody picks up for the next 40 years.
No, we don't want to do that. We don't want to do that. Yeah, I remember when you reached out to me when you were getting ready to put together a Geo Congress when it was going to be in Philadelphia, and although we kind of just missed each other at Illinois when I was graduating is when you were starting, but it was awesome to work with you, putting that together. And it's so much that happens behind the scenes, and it's fascinating that even as a professor, you're tasked to do these kind of things, and it forces you to tie back to industry, which I think is good for both sides,
Exactly. That's the intent. I don't really know, being a 3-time graduate of Illinois myself, I don't really know why other programs would do anything differently than have that handshake between industry and academics be as strong as possible. We don't get to shake hands as often as I'd like to anymore, but I think you get the idea that,
definitely
that handshake should always be there. We should be, our goal should be to work as closely as we can with industry. Otherwise, what's the purpose of what we're doing?
Yeah, no, you're absolutely right. I mean, honestly, students that are, they're matriculating in an institution and they're trusting that what they're learning is going to be applicable. So when you bring back, professionals that are doing this in a day in and day out, it really does help to solidify what they're learning. I can think as a grad student, those are some of the lectures I enjoyed the most, or when you heard about a case history or you saw something that didn't go right and how they were able to adjust things in the field. So those are good things. The proverbial handshake is a good thing.
Exactly. One of the biggest compliments that any student can pay me is that when they tell me the course they took with me was one that they use all the time, that they're always going back to their class notes and referring to their class notes when they're in practice. That tells me that I'm teaching them stuff that's valuable to them. And it's not just, again, things that are going to be stuck on a shelf.
Excellent. Excellent. Well, it wouldn't truly be a conversation now if we didn't say something about COVID-19. We've talked about it ad nauseum at this point, but
I imagine.
But teaching and researching in this era of COVID-19, I have to imagine that things have changed for you. So what kind of changes have you seen? Pluses, minuses? How are you adjusting? How are you pivoting? People like to say pivot. How are you pivoting at this time?
So we were really fortunate at Illinois. You're probably aware that we've been moving a lot of our content, particularly the graduate content, to be available online. We've started offering an online master's program for several of the departments in the Granger College of Engineering in Illinois, and it's been fairly successful. I've had in our graduate courses, I've had up to about a third of the class be online students, and
Wow.
I've had students from Asia, not from Japan, China, from had one from Australia, had a couple from South America, and all over in the United States. So it's really kind of interesting. It brings a new flavor. We're still working to the point where it is live, but when you've got students distributed all over the world, it's not always practical to do that live. So we've gone with more of an asynchronous approach in developing this online program. So for many of us at Illinois, it wasn't that difficult of a step to move into the purely online. It was the most difficult that folks had was in those really large undergraduate classes, which you can imagine would be really difficult, and in our lab classes, especially. Doing a lab online is just not the same thing as doing it in person, where you're physically touching things, whether it's soil or a geology lab or a chemistry lab. You can imagine that it's just not the same thing. So that's where our faculty had really been striving to provide a meaningful experience for our students. And going forward this fall, our plans are to have a hybrid system where we have students on campus. They are, in order to maintain that physical distancing that we have to, and to take into consideration the ventilation in a lot of the buildings, they're saying, for example, 1/3 of the students can go to class on Monday, the next third on Wednesday, the last third on Friday. So we've only got 1/3 of the student body in class live on any day, and then the rest of them can do it online. And so we're trying to offer more of a mix of live and asynchronous sort of education. So we're still learning. But again, fortunately, we were in a little bit better position than a lot of other schools to make this pivot to the online education. With research, it's been more difficult, because when the university closed down their classes, they also closed down all the labs.
Wow.
So all of the instructional, not just the instructional, but all of the research labs closed down. So I just now, toward the end of summer, classes are just a few weeks away. We're finally getting the students back into the geotech labs. We're finally able to do some of the field work again. I had students traveling out to UC Davis to use the centrifuge facility, for example. And all that was shut down.
Okay.
Yes, all of that was shut down, and we don't know when that's going to reopen.
Wow.
So the student's Ph.D., we had to completely shift gears on what this student was going to do, just in case he was unable to complete his planned his planned scope of work for his research.
Wow. And I have to imagine I'm sure that some of these grants have timetables and milestones have to get hit. Wow.
Yes. And fortunately, our funding agencies, by and large, have been understanding of these sorts of things, because they're undergoing, they're in the same situation as everyone else. So they're trying to keep deadlines and going from one Zoom to the next Skype to the next Teams meeting. You know how that is.
That's exactly the way it is.
Challenging. But it has forced our students to be, at least my students, that's who I've been speaking with mostly, to be more communicative.
Okay.
They've been forced to actually, instead of being able to come to me at any minute of the day in the office, they have to develop their thoughts, kind of develop questions, maybe send them to me in advance so I can think about them, and then we have a set time where we meet for a set amount of time, because just like everyone else, I've got another meeting coming up right after that.
Yeah.
So they really have. I think it's been a nice experience for them from that respect, not overall, but from that respect, from the point of view of having to really focus on communication and developing their thoughts. So pluses and minuses, just like with everything.
Got it. No, it's definitely key. I wonder, I think that, I've seen one of the challenges whenever I have to present now, it's all, it's virtual. So you're talking to a computer screen, but I envision it as a professor. It must be a little challenging. You don't really get energy back from the students. You can't tell people are checked in or checked out. How are you resolving that?
The end of the semester, after we closed down following spring break, was really odd, because I taught to an empty classroom, like a lot of our faculty did.
Wow.
So first the echo was really, was really bizarre. Not having students in there to kind of absorb sound. There's just all the classrooms echo, and you can clearly hear the instructors in the next classroom teaching, which was even more. So you're trying to talk over the next person. But what I tried to do then to make up for that lack of direct contact is I had immediate, well, our system uploaded the online content or the virtual content within about an hour after the lecture was captured.
Okay.
So then the following hour, I had a Zoom session with my students. So a discussion session, essentially, where we could walk through. So I'd open up the presentation and we kind of walk through different points in there, and I would try to highlight certain things and then allow for more question and answer throughout that. It made for more work for me because I had to, for every hour of classroom time where I do both the lecture and the question and answer, now I had an hour of lecture and an hour of question and answer.
Got it.
And then I held separate office hours so that I could go through homeworks or meet with students individually in that fashion. So it was a little bit more time consuming, but I think everyone seemed to make the best of it. And I had a good attendance at both office hours and the discussion sections most every time.
That's a good sign. That's a good sign.
Yeah, it's a little different, but again, everybody was, the good part of it was that everybody learned how to be flexible.
Yeah.
Even, I'm not a terribly flexible person to begin with. I'm not the biggest proponent of change, but I'm trying to realize that's the only constant. As much as that is a cliche, it certainly was the case last semester. It's going to be the case for this coming semester.
Yeah, no, you're absolutely right. There's as a design professional, one of the challenges we often hear people talk about is work-life balance. And I've talked to some of my mentees over the past few months, and they say all it took was a worldwide pandemic for you to start thinking about work-life balance a little differently. And the reality is we find a way to make it work. And the same thing as a professor, it's like we have to find a way to still be able to instruct the students. So that's really awesome. That's really awesome. Well, I look at your bio and I look at your history and what I know of you've won a lot of awards and honors for your research that's really been practice related and your teaching accomplishments. And one of those focuses has been on residual strength of liquefied soils. Can you tell us a little bit more about, I mean, of course, if it's top secret, don't share that part, but can you share some of the updates and some of your latest developments?
Sure. So up to this point, everyone, when you think of earthquakes and liquefaction, you think sands. And so most of my work up to this point and some of the things that had been recognized had been on how sands behave during earthquakes or under big slopes and within dams or underneath dams. Now the profession is realizing, and it always takes us a little bit of prodding to kind of recognize all of these different aspects of the same problem, is that silty soils may be subject to the same sorts of things. So most of the work I've been doing over the last couple of years along that line has been, how do all these concepts that we develop for sands really apply to intermediate soils, the low plasticity or non-plastic silts, the sandy silts, the clayey silts, low plasticity clays that may be subject to cyclic softening. And then how do we take those ideas and move from natural soils to anthropogenic soils, the tailings, the fly ash, and all these sorts of man-made materials that aren't exactly natural soils, but they're not exactly perfectly round spheres either that the physics guys can get into and really take over how things behave. So how do all these concepts for sands apply to these man-made materials or industrial made materials? And then given that we're now transitioning from sands over to more fine grain and clayey soils, what's the best way to evaluate these strengths? So the penetration test may or may not have the same meaning in a sand as it does in a clay. So can we use field vein tests? Should we go back to sampling and laboratory testing? And when you're in this transition in the silty zones, do we lean toward sand or do we lean toward the procedures that we have for clays? And so it's really again, that's more practice related, but it's a really critical question, because you're talking about, in the case of tailings dams, you've got hundreds of or tens of millions of cubic meters of this stuff being held up by sometimes very thin shells of stable material.
Yeah.
And there's been some really high profile failures of those sorts of structures in the last 5 or 6 years.
Indeed.
So how do we then take these concepts and apply them to practice, and what's the best tools to do that?
Got it. And what got you interested in that? You had somebody asked the question and you started to delve into it, an opportunity or a specific grant you were going after? I mean, how did you?
So it was from the beginning, early on. My return to Illinois for a Ph.D. coincided with the beginnings of the 3 earthquake centers across the country. And so historically, it was always centered at UC Berkeley, and that was the Pacific Earthquake Engineering Research Center. And in the late 90s, NSF funded 2 additional earthquake centers, one headquartered at Illinois, the Mid-America Earthquake Center, and one headquartered at Rensselaer Polytechnic Institute, the Multidisciplinary Center for Earthquake Engineering Research, MCER.
Okay.
And when that started up, I was asked to, actually, my advisor called me up and said, hey, do you want to come back and work on a PhD? I was a practitioner just like you. And on a project, I was actually away from home at the time on a project site. And I said, well, yeah, I give it the door's open. Maybe one day I want to teach. Why not? Why not give it a shot? And so it was essentially just the right door opened at the right time, and allowed me to kind of expand my skills and develop or get the skills that I needed, that I could open more doors in the future. And what I mean by that is, without a PhD, I wouldn't be able to teach really at the level that I might want to teach at one day. And I really didn't have a desire to go into academics at the time, but I wanted to have that option later in my career.
That's awesome.
So that kind of started me in that direction, and it has really just kind of evolved. Along with me and everyone else, my interests have evolved to some extent, but they've also kind of stayed focused on this liquefaction problem, and the problems that we apply it to have evolved in this case. So one of my colleagues from when I was working on my master's degree called me up one day and said, we've got this problem with the tailings dam. And this was 15 years or so ago, and that got me interested in tailings dams. The interest in fly ash and other industrial waste started in practice, and it was problems that I got thrown into as a practitioner, and I didn't have the answers to those problems that we had to answer. And you run into those sorts of things all the time, that there's the line blurs between practice and research at times, because we don't always have the answers to the questions that we're trying to solve.
No, you're absolutely right. I think that one of the biggest challenges, well, I should say challenges, one of the biggest eye openers when you start working as a professional is, you don't always have the given information,
Exactly.
And so what am I supposed to do with this equation? I don't have any of the given information. It's like, yeah, you have to go and drill or
That's right.
push cones, and you have to get those parameters. Oh, that's great. And, when you start to think about static and seismic liquefaction, you've been studying this for 25 years. Quarter of a century. That's quite a long time. When you think about the research that you've done, and you think about the different aspects of liquefaction, now we have listeners that are from folks that are in college and in grad school, all the way through to professionals. But what are some of the aspects of liquefaction that geotechnical engineers need to think about? Now, I know you could talk about that for 5 hours, but I mean, what are the things that come from a high level that come to mind?
If I could boil it all down to just one statement, it's that soil liquefaction is not a magical behavior. Wow. I once heard it termed soil liquefaction, because the engineer who mentioned that is a practitioner, and he mentioned that, and I just sort of kind of laughed, because I thought it was hilarious, because a lot of people do still picture it as a black box or some kind of magical behavior, and it's really not. It's just soil behavior. It's just stress, strain, volume change. And if you understand stress, strain, volume change of soils, you can understand liquefaction in all its different forms.
Awesome.
You understand those things: pore water pressure, effective stress, shear strength, reconsolidation. You've got a lot of the problems covered, whether it's a slope stability problem or a bearing capacity problem or a pile capacity problem or settlement following liquefaction. You've got all those problems in terms of your basic soil behavior.
Awesome.
And there's no need to think of it as some kind of separate magical land that very few understand and very few think is real. It's it's just soil behavior.
Awesome. That's a great way to put it. I mean, when that makes it a little less intimidating for the younger engineer that says, "Oh, I have to, have to go back to my integrals. How am I going to figure out this solution?" But you're right. It's the behavior of the soil, and the soil's doing what it does, right?
Mm-hmm. Exactly.
Oh, that's great. That's great.
And so that's what I try to teach in my classes, is just understanding the basics of soil mechanics will take you a long way in practice.
That's great. That's great. And when I think about your career, you do a lot outside of the classroom. You're a part of a number of professional societies. I won't name them all, but I know, of course, American Society of Civil Engineers, the Geo Institute, the North American Geosynthetics Society, Seismological Society of America, and a lot more. How do you factor in time to do all that, plus your research, plus teaching, plus handshaking with the professional? Like, how are you doing it? If you have extra hours, that sounds like magic. Please share. But seriously, how do you do it all?
I wish I had an answer to that, because I still, as you said, I've been doing this for a quarter century or so, and people have been doing longer. People have been doing less time. I don't know that any of us have figured out how to properly manage our time. I know I haven't.
Yeah, me neither.
So, but like you, when it comes to deciding which ones to do, which activities to participate in, I really look at it the same way I kind of look at research: is how can I best use my limited time to impact practice, or impact society. And so you mentioned us getting involved in the organizing committee for the 2019 Geo Congress. I thought by being on that committee, we could bring in some fresh ideas, and we spend hours talking through how to best do that, whether it's the geopits or the other things that we spend hours talking about. It's a lot. It's a good amount of time to spend, but I think we change the way that the ASCE is going to do things in the future. And I kind of look at it that way, that there's, of course, the importance of networking for a lot of professionals, and that's why they spend their time on that. For me, I look at it as, yes, I need to network, but also I want to try to make some kind of impact. So I get involved in things where I can hopefully make a bit of impact.
It's powerful. That's powerful. I think that, especially some of the younger listeners, they realize that, I have to go to the field, I have to learn my craft, and then I have to, find times to do other things. And I think that what you're saying makes a lot of sense. It's like, if you're passionate about what it is you're doing, then it makes it a little easier to spend the time doing it. But if you're not checked into what it is you're trying to do, it's going to feel more like a chore than something you enjoy doing.
And I think we've all been there. I know I have.
Definitely.
And those are the kind of things you just put off, and then you just make trouble for yourself and others. So so I've tried to narrow it down just to things that, like you said, are that you're passionate about. And for me, it's that I hopefully can make a bit of an impact.
Excellent. Excellent. When you look back at your career, is there anything you can think of that you wish you knew then that you know now?
Wow, that's always a tough question. Again, I think it goes back to that idea of change. That while I think maybe from an outside perspective, engineers are seen as kind of static and stoic at the same time, and not big fans of change. And I think I would count myself somewhat in that category, but understanding that even as an engineer, that the profession is constantly changing. You need to change to keep up with it. You need to expect that whether you're in practice or research in academics, I'm constantly learning new stuff.
Wow.
I'm involved with a project now where we have, or we're going after a project where there are colloidal scientists, chemists, physicists, and geotechnical engineers involved, and trying to tie all these things together. And it's really so I've had to learn about colloidal science. I've had to learn about nanoparticles. I had to learn stuff
Wow.
I never thought I'd ever touch.
Yeah.
But it's an interesting opportunity. And I said, well, this is research, so
Yeah.
why not try learning something new? And it I came to realize, especially as we started talking about this opportunity to do this podcast, that is the constant.
Yeah.
It's that you're always learning, and I wish I'd have known that earlier.
Wow. Okay.
Some of the learning might have been less painful.
There you go. You have a PhD, professional licensed engineer, and you're saying you're always learning. You never get to that point where you say, all right, turn off the learn meter. It's like we're going to keep taking things in. And that's great. I think that's what really keeps us all sharp and checked in, because you never know what you're going to be doing the next day. So that's pretty cool.
Yeah.
That's pretty cool. What advice would you give to a young geotech comes into your office and says, I'm at a point in my career where, I'm trying to get excited about geotechnical engineering. How do I get excited? What are some of the things you would share from an advice standpoint?
Well, the first thing I share is my story, because I think it's not that unusual. So when I started in civil, I like most everybody else, you think civil engineering, you think structures, and you think environmental. I started on the structure side. And I got into some of the structures classes, and the instructors say, well, open up your code book to section A.4.3.B, so on. And I was like, is this what civil engineering is really about? And even for structural engineers, obviously it's not about that. But when you start the education process with a code book, I was like, that really turned me off. What I like about geotechnical engineering, as I think a lot of geotechnical engineers like about it, is that uncertainty that's tied in there with it. Yeah. That it's natural materials, not man-made or artificial materials, that we can specify such that only 5% variance from your ideal parameters are accepted on a project, or it's got to be better than that. You can only have like a 5% failure of too low strength concrete, steel that doesn't meet your specs. We don't get that in geotechnical engineering.
Not even close.
There, yeah, exactly. Not even close.
Yeah.
And that uncertainty, or that variability, really attracted me. And the fact that there were no code books.
Yeah, it was like, also, pass me the geocode. It's like, we don't have one of those.
Of course, we're working on those sorts of things, but the way I look at it, the purpose of developing those codes is to make sure that engineers recognize that uncertainty is throughout our profession. Yeah. And we're finally trying to quantify that uncertainty, instead of just using big factors of safety or saying it's all engineering judgment. Yeah. And I certainly do not want to ever cast aspersions on engineering judgment. No. I think it's critically important for engineers to have engineering judgment, particularly geotechnical engineers, because every site, as I tell my students, you may sample 1%, probably much less than 1% of a given project site that you're going to influence with some structure. Mm-hmm. Out of that, you may test 1% of what you've actually sampled. So if you're drilling 10 borings across the site, let's say that's 1%. Okay. You're probably only going to test 1% of what you've actually drilled, because you're taking samples every 5 feet or whatever it is, mm-hmm. and you're testing only a fraction of those samples you retrieve. So it really requires a thorough understanding of a lot of different areas, from geology to understanding soil mechanics, rock mechanics, structural engineering, hydrosystems engineering. All of those kind of roll together to become a good geotechnical engineer. And so that variety and that uncertainty really attracted me. And if those things don't scare a student off, or somebody who came into my office asking about it, that doesn't scare you off, maybe this is the right field for you.
There you go. It's either going to scare you off or excite you. So that's a good way to put it. It's a good way to put it. Yeah, you think about it, there's really not a lot that you're using for this design. So there's a lot of other variables that come into play.
Right.
Oh, that's great.
And when students ask me about all the new some will ask me about new developments in geotechnical engineering, like biogeotechnics or geosynthetics a few years back, and other things that are new. I keep coming back to the same answer, that if you understand the fundamentals of the soil mechanics, rock mechanics, geology, and those others that I listed, if you understand those fundamentals, you can then learn all these other new things that come up. That
True.
is not that difficult if you have a good grasp of how soils behave.
Well said. Well said. Well, thank you so much. We're going to come back in just a minute to close this one out with Professor Olson and our career factors safety end segment. Stick around. Welcome back. It's time for our career factor of safety end segment. And in geotechnical engineering, just like many disciplines of engineering, we hinted at this earlier, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? So today we're speaking with none other than Dr. Scott Olson, PE. Professor, we spoke to you earlier about the things that you accomplished in your career. What advice would you give to geotechs listening for how they can advance their career? And that could be moving up in the professional world, or moving up as a professor, or maybe even making a change from, professional to academic as you did. And how can they do that to secure a factor of safety in their career?
That's an interesting way of putting that question. I had not heard it that way before, but I like it. I'm going to use that if you don't mind.
Go ahead.
The two things that I always encourage students to do when I put on that mentoring hat is to first get as broad of an experience as you can when you go into practice. And so even my PhD students who really strongly want to get that first academic job and jumpstart their career academically, I push them as hard as strongly as I can without being too forceful into practice first. Because if they get into practice, even for just a couple of years, the experience they're going to gain and the variety of things they're going to see far outweigh what they're going to do those first couple of years in academics. And I always come back to one thing when for those sorts of students is you need to understand what the questions are that you want to address through research. Where are the knowledge gaps? And if you don't understand where the knowledge gaps are, like I said earlier, the questions that you can't answer when you get involved in a project and you just don't know what that right answer is,
wow.
That's research.
Wow.
That then can develop into research. So a lot of my research has developed from those things that I ran into in practice like that. So that's one of them, is that desire to keep trying new things, because it will help you develop that engineering judgment that you need to have in this profession. And then making switches, I've never been a huge fan of making switches. And for me, maybe I've been lucky that way, that it's just keeping your eye open to what doors and what opportunities come before you. Because I strongly believe that even people that feel they're stuck, there's always an opportunity out there, even if you don't know what that opportunity is. But if you prepare yourself to look for those opportunities and you're willing to walk through that door when it does finally open, then you can make the change to make your, to advance your career and add that factor of safety to what you're doing.
Awesome. Well, thank you so much, Professor, for coming on and sharing these great insights with us. And thank you for all that you do as an engineer and impacting our great society. We appreciate that. You've given some great information and great advice to our listeners. What's the best way for them to reach out to you if they wanted to learn more?
The best way is to simply email me at Olson's. So olsons@illinois.edu, or simply type into their search engine Scott Olson, and don't select the one for the photographer for the AP. There's two Scott Olsons that will come up. I'm the geotech, so maybe type in Scott Olson Geotech.
There you go. All right, thank you so much for coming on. It's been great.
I appreciate you inviting me to be here. It's been a lot of fun. Thanks, Jared.
Awesome.
I hope you enjoyed our episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 12, as well as links to any of the resources, websites, or books mentioned during today's episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.